Hello friends. So as of now, we have seen or we have find out ultimate bearing capacity for different types of footings and also for different types of failures like general shear failure and the local shear failure. As of now, we have done all the problems by assuming that all the soil or all the problems are in a dry state. But if there is a water table, then from present videos, we will see how to consider the effect of them. Okay, for that, let us understand the bearing capacity terms given by the Terjagi. After that, we will see one by one. So, if you recall the bearing capacity equation by Terjagi, what is written there? For the continuous footing and failing by, let us say, general shear failure, C into NC plus gamma D NQ plus of into gamma into B into N gamma, right? Suppose if I divide this entire equation into three different parts, let us say this I'll say one term. This is because of strength is achieving because of due to cohesion, isn't it? Due to cohesion, we may have some capacity. And what about the second term? See here, gamma D into NQ. So this is nothing but a due to depth. Due to the depth of the foundation, if your depth is more and more, then your capacity will also increase. So this second term is including the capacity of a soil due to the depth of the foundation. And similarly, if you see this term related to, can you tell me, due to, what is the term there? B. B is nothing but a width. So what we can say? We can say simply due to width of the footing. Right? So first term, it is due to cohesion. Second, it is due to depth. And third one, it is due to width. Okay. So always while finding this bearing capacity, we have to consider the effective parameters. Okay. We should not consider the total stress parameters. Always we have to consider the effective parameters while evaluating the bearing capacity equations. So suppose if I draw a foundation, let us assume that this is your footing and let us assume that this is the ground surface level. Let us say this is nothing but a ground surface level. And at the base of footing, let us consider this is the level of foundation. Level of foundation. So from here to here, what is the width? From here to here, if you denote it, this is nothing but a width of the footing. This is normally representing by B. From here to here, we will call it as a depth of the footing. Normally, we will represent it by parameter D. Okay. Now, suppose in our reality, our water table can be anywhere. It may here, it may be under the footing, or it may be in between the footing, or it may be above the ground surface. So we have to study about if your water table is at the different levels, how to consider the effect of them, that we have to study here. Okay, that means let us say, so from here to here we are talking about the depth of the foundation. So because of this depth, we are our capacity of the foundation is increasing. That means this is what related to the second term, isn't it? From here, what is the term? Gamma D into NQ. So if there is any water table here, then it will affect the second term. Similarly, it is found that there is some another layer you have to imagine. So that layer is at a distance of B below the base of the footing. Remember, it is B below the base of the footing. So because of this, we are having the capacity of the foundation. So that's why this term is related to, I'm simply saying it is a thought term. Okay. So if I divide this into the number of zones, what I'll say is that the total how many zones are there? If your water table in between ground surface to the level of foundation, then I will call this as a zone 1. If your water table is in between level of foundation to the up to a level of B, so this I will consider it as a zone 2. Below this level, I will consider it as a zone 3. Okay. So if your water table is in zone 3, suppose if your water table is here, how it will affect the bearing capacity? If your water table is here, how it will affect the bearing capacity? If your water table again it is here, how it will affect the bearing capacity? Similarly, in reality, it is not always mandatory that your water table will exact be at the zones. It may be somewhere here and also it may be somewhere here. So what are the effects? How we have to consider them? Those we will see here. Let us say if your water table is in zone 3. Let us consider first case. If water table is on, let us say simply what I'll say, if your water table is in zone 3, that means in the present case, let me simply draw a foundation, ground surface, and this is another layer, and this is also another layer. So from here to here, we will call it as the depth of the foundation. This layer will be at a distance of this width of the footing. So this level, below this level, it is called the zone 3. That means if your water level is up to zone 3, that means from here it can go anywhere, doesn't matter. That means the most case is here. So this is also a dry and this is also a dry term. So is it affecting water table? Is it affecting any of this term? What is this term? Second term. Is there any water table here? No. That means in up to a depth D from ground surface, our soil is in dry condition. That means you have to use gamma. Similarly, from the base of the footing to the at a depth of B, here also the soil is in the dry condition. That means here also we have to consider gamma. So simply we can say if your water table is below the at a distance of B from the base of the footing, then this water table will not affect anything to the bearing capacity equation. That means your bearing capacity equation will be simply nothing but a CNC plus gamma D into N cube plus 1 by 2 into gamma into B into N gamma. If your water table is here, then it will affect the third term. If your water table is here, it will affect second term and also it will affect the third term. Okay. I think hope you are understanding here. So this is what called the third term. So as your water table is neither in the second term nor in the third term, that's why if your water table is in the zone 3, it won't affect the bearing capacity of the soil. Understood? Hope for everyone it is clear. So in the coming videos, we will see what will be the effect of the water table if it is in the third term or if it is in the zone 2, and also we'll see what is the effect of this if your water table is in the zone 1. Okay. In the next video, we will solve a problem based on this model. That means if your water table is in the zone 3. Okay. Thank you.